Hello, my name is Roberto Riva. It's the 26th of March, and since we are all in self-confinement due to this malefic coronavirus, Jeff Locke, creator of StimMax, this biodegradable nanotechnology product, and myself decided to do a little video to show some lab tests, one professionally done by Interweb, PDVSA, and Rosneft, which I'll show here, and the other one that Jeff did in his house with his kids swimming in a pool, which shows the biodegradable and environmentally friendly quality of this product.
Good afternoon, Roberto. Per your request, I am filming this video for your benefit. It's so easy, I'm actually doing it in my backyard, and I have my son even swimming. What I have is the Plus Patrol CE 1224 pulled from this year. We're going to put StimMax pads for paraffin, asphaltene, and sludge, or scale, I should say. And we have 500 milliliters of Plus Patrol, and we're going to insert 20 milliliters of pads that's already been pre-inserted into this little jar. I'm back, Roberto. I'm actually going to insert the pads. Again, that's 20 milliliters. And you can immediately see how it's already separating. You got 3 levels of separation. I'm back. I just put the cap back on, and with some slight agitation, let me just slick it up for a little bit, swirl around a little bit. See how the oil that was sticking to the sides of the glass is automatically coming off. You can see the water separating out of the oil. You can see a sediment layer between the whatever was in the oil and the water, and then you'll see the crude actually floating on top. Again, the benefit of our product, as you know, is to improve flow, and this is a real simple experiment that just shows the separation, the lifting, and out the door it goes. The protective coating you see on the glass will be the same kind of protective coating you'll see inside the reservoir, within the pores, and any kind of water and oil emulsion or oil and water emulsion will won't stick to the walls, again enhancing flow. Round 2, Roberto. I'm taking a look at the crude from Peru, pulled on February 17th, 2020, lot number 12012. Again, I'm taking 20 milliliters of PAZ, and I'm going to inject it into the crude samples that was sent to us. You're going to immediately start seeing, again, the separation breaking down. Let me agitate it, and I'll turn it back on. And the Peru samples are already starting to break down. I will add water. I'm going to add water to the Plus Patrol because theoretically, as you can see, nothing is sticking. What we'll do is we'll just assume that we're using a water or a brine or even a diesel for that matter as a displacement, and then watch the separation begin. Okay, Roberto, now I'm going to throw in, let's pretend there's some displacement going on. I'm actually putting in around 1,000 milliliters of water. This pushes the product deep into the reservoir to get into all the pores. Again, think nanoparticulates. And it's going to start stripping and breaking any emulsion. It's going to restore permeability, and we'll start shrinking the clays. Well, Roberto, upon some agitation, again, you can see how how this layer is coming up, this layer is coming down. There's a sediment layer in between, and the whatever leftover crude that's still sticking to the walls of the glass are slowly peeling off. Again, I hope this is helpful. As with the Plus Patrol sample, where we added about 500 milliliters of water, we've added around 200 milliliters of water to the Peru sample, and you can see how it's breaking down. I'll do some agitation. With a little agitation, totally dislodged. Again, hope this is helpful.
The last two test photos are what happens in the well after soaking for 12 to 24 hours. You will have a layer of oil, the solids in liquid form, and the water. And